everyone. Welcome to another session of TestMu 2025. I'm Sriharsha, Engineering Manager here at Lambda Test, and I'll be hosting for this session. Today, we are going to talk about a really important and interesting topic, network control for end-to-end web testing. Now, if you think about modern web apps, they make tons of
ये प्लेटफॉर्म साइड देते हैं, बट वी आर एक्सपेक्टिंग
during a single user flow.
एग्जैक्ट
When we are interested in end-to-end tests, it's not enough to just click through the UI. We need to see what's happening behind the scenes, mock some of those calls, and make sure our tests are reliable, complete, and easy to debug. So we'll be looking at some practical ways to do that, including tips and tricks with Cypress and a record, play, replay, inspect path with API mocking. Before we dive in, just a couple of quick reminders. This session is recorded, so if you miss anything, don't worry. You'll get the full recording in your email, and you can also find
3941
it in Lambda Test YouTube.
कुछ तो कहता है बेटा
And if you have any questions, please draw them. Please draw them.
इसमें हिसाब से 3941
आज का
आज के नहीं
All right. With
Using
out of
that-
the way, my absolute pleasure. The speaker, Gleb Bahmutov.
एयरमीट का तो लिंक मैंने आज ही शूट किया है
Hey, everyone.
LCM लगाया है
बेसिकली उस लिंक से
Thanks
लोगों
for
ने
inviting me.
ज्वाइन किया वो भी है
I'm Gleb Bahmutov,
Registration is
and
included.
हाँ
I'll do my presentation
अच्छा
on
ये मतलब
network
इस लिंक से
control
3941
for end-to-end web testing. You can find my website at gleb.dev, and I want to thank Lambda Test for organizing the conference. I hope that everyone is enjoying the presentations. And my slides are already online. They're public. I put the link in the resource tab here. Before I begin my presentation, I'll just put a slide right here. We're living in the middle of a climate crisis. The heat waves, the wildfires, the droughts. It's not going to be a problem for our kids. It's our present problem, and it's going to get worse until we stop burning fossil fuels. I'm an optimist. I believe that a better world is possible, but I don't think we can do it separately. I think we can have to work together, and only by joining an organization you can actually solve climate crisis. So every country, every city has something like Greenpeace, 350, Sunrise, Citizen Climate Lobby that are working to solve the climate crisis. All right. I'm online. Everything I do is public, from open source on my GitHub account to my blog. I blog a lot because I forget everything I do. So if I don't write it down, it's very difficult for me to kind of do it again and just know that if I've written it once, I would not have to reinvent it. I have a YouTube channel where I post videos, solving different testing problems. And I'm a senior director of engineering at Mercari US. So thanks for attending my presentation. Everyone is welcome. I'm looking at the chat. I see some familiar names. So welcome. I even do online courses, so you can learn secrets of testing yourself without even me being present. In my day-to-day life, I work at Mercari US, which is mercari.com. It's an online marketplace. If you have something you're no longer using, it's easy to sell to someone else, kind of to give a home to the things that you no longer need. And I think it's good for the circular economy and for the environment. We do a lot of testing at Mercari. Literally, everything goes through end-to-end testing, in addition to unit, API integration testing. I've done presentations on how we do testing at Mercari. I've been there for years, so a lot of things we learned and experienced, I describe them in those slide decks. You can find the presentations at slides.com. This is a typical Mercari end-to-end browser test. I'm using Cypress. You can see the browser. This is a live browser recording. On the right, you see Mercari website. I'm going to the item. I'm communicating with the seller. And these test commands are reflected in the column on the left. So everything you write in the test, you can watch it live being done in the browser. You can see each command, and as it happens, you can see the browser executing it. So very, very easy to understand, easy to share system of end-to-end testing. I really love end-to-end testing. I think it puts focus on the right user, on the human user of a website. It doesn't stress the importance of units of code or implementation. It literally makes sure that when a human being wants to buy something or sell something, they can go to Mercari.com, they can find the item, click buy, enter the details, and the transaction happens. Unfortunately, if you do a lot of end-to-end testing, there are a couple of downsides. A big downside is that you actually need the deployed application, right? So you need to have a preview environment, or you need the dev environment, staging environment, or even production, and it has to work, and it has to be full deployment, which means also deploying all the API and application servers, and that could be difficult because it is slow, right? And we also have a downside of end-to-end tests being slow because, well, we have to visit the full web page. It has to load. Every time we click on a button, it has to make a call, usually to the backend. It has to return, and before we can actually test and conclude that the website is working. For my presentation, I'm going to take a much simpler website. I'm not going to take Mercari.com. I'm just going to take to do MVC. You can find the full example in Cypress Magic Backend example repo on my GitHub account. It's very simple. You enter items and they're shown to you. You can complete items. And if you open the DevTools, you can see different calls the page is making in the process of adding items or completing items or deleting items. And there are two different types of calls that a typical web app is making, right? Well, there is the web part itself, the HTML file. It has to be served, including styles and JavaScript. Now, that is very simple because these are static pages. There are lots of technologies for serving static pages quickly and reliably, like Nginx, Apache. I'm using GitHub Pages for a lot of my stuff. But you can also see different types of calls, right? The AJAX or XML HTTP requests, as they're called, right? For example, fetching items stored on the backend is more complicated than serving just a static page. You need to have a backend, usually implemented in Node.js, Go, PHP, Java, or whatever, right? It has to be running and receiving, and there is authentication and all that jazz. As I said, serving static resources like HTML, CSS, and JavaScript is very simple. Could be cached, that's fine. The API calls, on the other hand, are complicated because you need to deploy the web servers. You need to think how you're going to cache data. You need to think about speed and so on. So a typical end-to-end test, for example, if it deals with data, probably needs to reset the data or control the data. And then it can interact with application by visiting the site, entering the items, clicking enter, confirming that the items are there, reloading the page, and so on. So this would be an example of adding a to-do. In this case, I'm adding 2 items and then confirming that there are 2 items in that to-do MVC. So by the way, this is a video, so all the slides include these little video loops. So I think anyone who wants to look at this presentation will have a full context if they just flip through the slides. I specifically didn't want to do live demo. I recorded my screen for this presentation. So you can see the application is working, but the test is slow. And you can open the DevTools and you can figure out why. Well, because my API calls in these specific examples take 1 second each. I specifically slowed it down just to prove my point and make a kind of representative example similar to the real web application. Okay, so that's our first problem. If we have a backend that's specific to our application and we make API calls, the first problem that we usually find is that testing is complicated by needing that app server specific for our tests. If we didn't have it, right, it would be so much simpler just to load HTML, just to load CSS and JavaScript, and have just the browser part. And second, our tests are slow because API calls going to the database, especially if we don't have a lot of machines in our preview environment, our dev environment, then they are slow and people complain about it. If we didn't have a backend, everything would be so much faster. And if we have a backend, usually if we have multiple test runners that need to access the shared backend, when we cannot usually test in parallel because we have to think about the data not clashing. Because if I have multiple clients and they each add an item and we have a single shared database, well, now I don't know how many items I will see. I will not see just a single item. I'll see from 1 to 10 items. So if we didn't have a backend, everything could be done in parallel. So this is what prompted me to write a plugin for Cypress to allow me to record, replay, and inspect the API calls. And here's how it works and why this is a benefit to your end-to-end testing. So first things we need to do, we need to record our realistic API calls the application is making if you just interact with a page. If you think about it, which calls does my application do if I open DevTools and just interact with my application, or if I watch the test interact with application? In this case, I need to get to-dos, so get/to-dos. If I'm adding new items, it would execute post/to-dos URL calls. And if I'm deleting, then it will delete/to-dos/ some kind of ID. So in my plugin, you can configure the routes to observe and record. Okay, so it would look something like this. In Cypress config, I can put Magic Backend because my plugin is called Cypress Magic Backend. And I can say, well, intercept the calls that have method get or post to the path name /to-dos, or method delete/to-dos wildcard. And what do we see? So this is me running 6 seconds. Then I click on the record button that I add to Cypress, and it shows, a little bit more UI, and then I can find a JSON file in Cypress Magic Backend folder with all the calls, both requests and responses, recorded as JSON. Okay, so the test is the same. It's making real calls and then dumping all the calls in the correct order into a local JSON file. And the local JSON file looks like this. We have the name of the spec right here. We have the name of the test. And then we record every call that happened just in order. So for example, we can say the first call that the application made was to get to-dos. The application didn't send anything in the request, but it received an empty response. I also record how long it took in milliseconds. Okay. And then the test added a new to-do. This is a to-do it sent, the response it received, and again, it took 1 second. Then we added second to-do, that's this object. And then the application did a reload and received 2 to-dos from the backend. Again, we're recording whatever the application did and the server sent back. Okay, so what can we do with this information? We can replay those calls. Okay, so there is another button that I add to Cypress UI. It has this magic wand and the video tape. And this is what it does. So first, we have the calls, and then if I click on that button, now notice a couple of things, right? The test now takes only 2 seconds. Instead of 6 seconds, it now takes 2 seconds because we are not making the real calls to the backend. We load the page, we load the CSS, we load the JavaScript that is static, But then anytime application is making XML HTTP request, we intercept that call and we just send back the pre-recorded response from the JSON file. And obviously, if we don't have to spend 1 second going to the backend and waiting, the test is much faster because we instantly respond. 2 seconds instead of 6. Already pretty good. We can also fetch, or not fetch, that's the wrong name. We can look at the current mode inside our test and ask, am I recording? Am I not doing anything? Or am I replaying, right, the API calls? And so, for example, instead of just blindly resetting the data on the backend, if the mode is the playback, well, I don't need to reset anything because I know I will never go to the backend. So we can avoid making the initial reset call if we're in replay mode. And what this leads to is the following. If we just replaying the test, if all API calls are mocked, then our test is much, much faster because it never has to go to the backend. Okay, so now it's 600 milliseconds. So from 6 seconds, we went to 100 milliseconds. So we actually improved our speed of end-to-end tests 10 times. Everyone wants to be a 10x developer. Well, you are a 10x developer if you are recording and replaying real API requests. We can go even beyond that, right? We can improve the speed of testing even if we're not touching the API. So let me show you how. I have a plugin called Cypress Watch and Reload. So by default, Cypress only watches the spec file, the test file with all the tests. And if you edit and then save it, it will automatically rerun the test. But I have Cypress Watch and Reload that can watch additional files because, as I said, your web app is not just the API calls, it's also HTML, CSS, JavaScript. So we can say, okay, watch this file, index.html, and watch app.javascript. And if you use the replay mode with pre-recorded API calls, if you don't have it, when the test takes 6 seconds. But if you click on the replay and you say lock it, then anytime, for example, you're modifying the HTML file and you save it, it immediately reruns full end-to-end test. So you immediately know if your web page HTML is still valid and if the tests are still passing. It saves you all the waiting time. You can edit HTML, you can edit CSS, and instantly, or almost instantly, rerun the full end-to-end test. Because if you're modifying HTML, you probably don't care about the actual API call. As long as it is the same, right, it probably should be fine. So much faster end-to-end testing. Well, this button, the first button with a camera, is for recording API calls and saving the JSON file. The second button that I showed is for replaying. So what is that button? The third button that the plugin adds. So it has the magic wand and then kind of like, confused emoji. Well, that's my favorite button, to be honest. It's called the inspect button, and it allows you to do something cool. So right now, this is the test, right? Takes 6 seconds making actual calls. That's fine. Right? And all of a sudden your test runs, but it takes 8 seconds. And you like, why is it slower? So you can click the inspect button. And what it does, it actually makes the real calls, but that it compares them to the pre-recorded JSON of calls. And if it finds, for example, the difference in duration, it can warn you right there in the column where all the Cypress commands are shown, all the assertions are shown. Okay, so let's watch it again. So this was original, 8 seconds. Now investigating, and we're clicking inspect. it's making actual calls, but that it compares durations. And if you click on the warning in the command log and look at DevTools, it shows that this particular call used to be 1 second, now it's 2 seconds. It slowed down, right? Just by looking at the difference with pre-recorded calls and current calls. And you can investigate. You now know that this is why the test is suddenly slower. But it's not just the timing. Timing would be kind of cool already, but we can do much more. For example, you can have a green end-to-end test that is passing. But if you look closely on the page, or to the page, or at the page, it's to do MVC. There are 2 items. I can see the 2 checkboxes, but for some reason, the text is missing. Well, the test is still the same. It entered 2 items and then confirmed there are 2 to-dos. But as a human being, I'm looking at the page and I was like, something doesn't look right. So what has happened? Well, again, if we have normal mode, the test is green. But if we look at the inspect mode and click on inspect button, again, it inspects not just the duration, but it inspects the objects sent and received with each call, and it warns you that this post to-dos added the key text and lost the key title in the object it sent. Okay, because it recorded the objects sent and objects received back. And it tells you the shape of objects sent now is different from what I had recorded. It modified one of the objects. And maybe that's why the empty to-dos. And the whole reason why is because the smaller the surface of code you have to understand and debug, the simpler the debugging is. So if you think about interacting with a web page, and the web page sending API requests to the backend and receiving responses and then rendering the result, the user action happens in a browser. Some JavaScript code that you've written for a front end runs in a browser and does something with user input. And then it sends an object with a request to the server side. The server side does some processing, goes to the database, whatever it has to do, and sends the response back to the browser, where, again, some JavaScript code labeled C right here processes the response and renders the to-do list or some kind of DOM object. If you don't have separation, all you know is the problem is somewhere in a front end A, front end C, or in a server code B. But if you know previously passing recorded API calls, you can inspect the current objects sent and received, and you can easily figure out where the problem was. So, like I said, in our test right now, it says that the object sent by the front end to the back end is different. Used to be recorded, title, completed, and ID fields right here. And now the request has text, completed, and ID fields. So something changed in the front end before the API calls goes to the back end. So we know that the change and the potential problem is in the front end JavaScript code block A, and not on the back end. Well, could be also on the back end, but we're sending something different this time. Okay, makes the debugging much simpler. Okay, so we have an inspect mode. It compares API calls, but actual calls, we're not stopping it this time, we're just observing it and comparing it to the previously recorded calls. We can report timing changes, so we can figure out if something slowed down or sped up. And we also report schema changes, but we don't look at the values, right? Values probably would be interested or could be compared using end-to-end assertions. We're just trying to check if object has the same keys and not unexpectedly renaming or removing fields. Just for myself, I wrote a little backend as a server, or Magic Backend as a service, where I don't save the JSON files locally. All I do is just I tell the plugin store the API calls remotely, pass the API key, and then it works. So I don't have to mess with JSON files and update it. And it looks like this, exactly the same, just doesn't save the JSON files. And I think once you start storing requests and responses for multiple test runs, you actually have a repository of gold. And this is a very big change from how we treat CI. We usually treat the CI as something we have to pay for, and it just passes, and no one ever looks at the green CI runs, right? When was the last time the test passed and you're like, okay, let me look at how they passed and what they did? No, you don't care. They passed, boom, you merge a pull request. But with recorded API calls, even the successful ones, and especially successful ones, are a gold mine. And let me show you why. So this example is much simpler than even to do MVCs, just for demo purposes. So the test enters a value in the input field right here, clicks send the number, and the server responds. The test is green, send 2, the server response was 2. And our numbers that the test sends are not hard-coded. Usually, our test should be deterministic, but imagine we're sending numbers between 3 and 30, and if you change the mean value to be negative once in a while, you might send a negative number. Okay, so let's see how it works. All of a sudden, after multiple successful test runs, you get a failed test. Okay, and here's where the debugging becomes magical. Okay, so here's me entering a negative number, or the test entering a negative number, and you're like, what happened? Right? So we look at the inspect mode, and the inspect mode not only tells you that something went wrong, it actually pulls the history of requests for that particular place, right, in my test. And it tells me for all the successful tests, here was the request and corresponding response. And the same for the failed ones. So I can inspect the calls in this particular place in the test, in my app, and see, every time the number was negative, the test failed. And every time the number was positive, it passed. Okay, so I think the difference was in the positive versus negative inputs in this particular field. Okay, so I'm using all the pre-recorded or previously recorded successful test executions to give me more information that allows me to instantly debug the problem in this case. And imagine doing this for flaky tests that fail maybe once in 1,000 runs. What was different about this particular test? Having the history of successful test runs and all the details, and then showing it, and there's a huge list and statistics. You can immediately debug and say, oh, the problem was number cannot be negative. And we can go beyond just manually looking at this. Right now, AI is all the rage, so I could not have this presentation without some AI. Instead of doing MCP server or doing anything, I think majority of tools right now, in order to be successfully useful in the age of AI and LLMs, need to provide everything they output to the user into the format that can easily be ingested into any prompt as context. So the plugin Cypress Magic Backend does this. So I'm running the test, and if it fails, and it will fail in a couple of runs, like right now, if you go to the terminal, because it also outputs that information in a terminal, notice it says AI prompt copied to clipboard. The same information is now on my clipboard. I can go to Copilot, open the chat, paste what the tool plugin copied, And then Copilot immediately says, seems like any negative input leads to a failed test. AI is smart enough to look at 20 tests where I mark each test with pass, fail, give input objects, output objects, and AI is, I mean, the problem is simple enough to say, okay, every time I see a negative number, the test fails. Every time I see a positive number, the test is successful. So the automatic prompt context just explains the API calls and the history. So you can use any LLM to answer that. And it just works for simple things. All right, so that was Cypress Magic Backend plugin. And if you think about it, recording, replaying API calls makes the test much, much faster. Among all the pluses of this plugin is the speed. The tests become independent. I can launch multiple tests on multiple machines and run them in parallel because they never share the same backend anymore. All the tests are independent of the app server. They help with debugging because I have all the information I need about the API calls when the test is successful versus the current test that maybe failed. And what I like about end-to-end testing, and especially a record of API calls, is that when I'm discussing with someone how my application is working, what does it send to the backend? What is the expected response? How do individual items look? How do I update or delete a to-do? Now I have a record, precise record of my test and all the communication with the backend. If someone comes in 10 months from now and asks, did we send that field? What was our ID in to-dos? Was it UUID? Was it underscore ID? I can look at the JSON file and say, we expect to see ID field. And usually it's a number or a string or follows a certain format. Our tests and API calls are a record. Well, of course, if there are positives, there are some downsides. We assume that each test makes the same calls. Otherwise, we would need to kind of figure out which calls maps to which call, right? We assume that our tests are deterministic, that they interact in the same way with the page, and then the application is making the same sequence of calls. And it's really hard to handle, let's say, non-deterministic data, like, for example, time-sensitive data. If the calls and the information we send depends on, let's say, timestamps, it's very hard for us to record it and then maybe update it when we substitute the pre-recorded responses. And also, if we have JSON files and something is out of date, obviously we have to maintain it, right? Maybe we have to update the JSON files. Maybe we have to re-record API calls before we can use the new front end. The maintenance cost is present. It's not free. If you want to learn more about Cypress Magic Backend, it's on my GitHub. I linked a couple of blog posts that I've written. Even a couple of videos are there, kind of showing it in action, in addition to this presentation. And I want to finish my last 3 minutes with discussion of open source, right? So this plugin is open source. It's on GitHub. It's all great. I have almost 400 plugins and libraries that I host. I've been doing it for a bunch of years. And everything takes time and effort. Constantly, I have to make a decision. How do I spend my time? Do I work on a plugin? Do I fix an issue? Or do I just go for a bike ride? Or do I enjoy the sunset? Or do I enjoy like coaching my youth team that this summer won a couple of tournaments? We have the best in-town recreational team under 14 among all the New England teams. We can play, we can beat everyone. We'll try to prove it again on Saturday. Because if I don't do that, if I work on my open source, it takes time, all right? And there is no numerical compensation. Even with all my projects, every month I get $20 from Sentry. Sentry is an excellent product. I highly recommend them. I love what they do. They do donate money and distribute it across multiple open source projects. But if you think about, if you have a successful open source library or dependency that everyone's using, well, you're not getting paid, right? The whole internet can depend on your little utility, and you just maintain it for the love, right, of programming. And the question is, can you continue doing it? What happens if I'm no longer there, right? It's very hard to make it sustainable. It's very hard to call it fair, okay? And what I've been doing was, for example, this is my blog. At the bottom, I'm saying, okay, I have like my blog posts, projects, presentations. You can sponsor me through GitHub sponsor. So I get like $20 every month from my generous GitHub supporters. That's great. And I sell online courses. So what I look at for my open source work and this presentation is kind of like, okay, at some point, someone will buy a workshop or online course, and that will be the reward, and that will be financial thing kind of motivating me to spend time. I cannot do it full time though, obviously, right? Because I don't get enough payments to kind of quit my current job and work on this tooling. So is there a better way? And I'm almost done, so just a couple more slides. What I started doing right now, and Cypress Magic Backend is one example, where the license is not MIT or open source like that. It's Polyform Small Business License, which means if you work at a small company or individually, right, or open source, nonprofit, under 100 employees, it's completely free. Feel free to use it, everything. But if you work for a commercial company, over 100 people, then you have to buy a license. It's very cheap, but it's no longer free. Okay, so Polyform is very nice, has a very nice list of licenses that you can use depending on your situation. So you don't have to put MIT on everything. Okay, I picked the one that's free for small projects, individual projects, but small fee for large companies, because that pays for support, that pays for my time. So I'm not sure if this is going to be my kind of standard thing a year from now or 5 years from now, but I've been doing open source for the last 15 years. So I hope that because I love open source, that I can find a solution and other people can find a solution that works for all of us in a long term and make it worthwhile. Okay, thank you very much. The slides are online. If you have any questions, I'll be happy to answer. Thanks to Lambda Test again for this conference. I really am enjoying it and I enjoy speaking. Okay, thank you.
Wow. Thank you so much, Gleb. So those were some wonderful insights on handling network control in the end-to-end testing. And I'm sure everyone here picked some really practical tips to take back to their own projects. So as we have got some time for the Q&A, I'll go ahead and pick the first one from the Q&A panel.
Okay.
First question is, how can record, replay, inspect pattern for API mocking help reduce flakiness in E2A tests while still ensuring realistic coverage of critical user flows?
So flakiness can come from multiple places, right? A big place, like in my company, in dev environment and preview environments for pull requests, is that they usually are underpowered. And number one concern is that sometimes the application is making requests and one or two machines trying to process for that environment, they just cannot handle the load. And we get 500 errors back. Okay. So that's very like this just kills me in my day-to-day job, right? With like transient, 500, the server is not there yet, but then 30 seconds later it's responding, it restarted. So by recording, you separate the front end, the static server, which like can handle millions of visitors, from the application servers that are usually much more resource heavy, and so you can run lots of tests without those transient errors. I don't have it implemented, but one of the ideas that I had for this plugin was a mode where you can say, okay, run the test, use real requests, and pass the real response. But if the server has an error, like 500 error, and doesn't answer, well, send the mock response at least. Okay, so that the front end doesn't stop the test because there was a little hiccup, that's temporary. So I think that's like number one thing, where you don't need the actual application server that can just not be there for like a fraction of a second and then continuous. Okay.
Got it. So I'll put the second question. So what tools and techniques are most effective for controlling network conditions like latency, bandwidth, and packet loss during E2E testing? Maybe you can suggest a few from your open source tools.
Well, one thing you can do, and I do it in my end-to-end tests as well, is that I have specific end-to-end tests that exercise your front end in cases where a response, for example, takes longer, right? It's like I specifically delay sometimes the API call by a couple seconds just to see what does the page even show during that moment. So think about when you visit the web app and there is a loading screen. Well, on my powerful machine with local thing or in production, it could be instant, right? Like just a flash of a loading screen and then it continues. But on a slightly slower connection, that loading screen can show for a couple seconds. You have to test this, right? So in my end-to-end test, sometimes I slow down loading just so I can test the loading page. And more than that, not only you can test the loading page, you can test what happens if a user sees the page and clicks on a button while the backend is still loading, right? Like the page is still loading JavaScript. Because oftentimes our forms and our buttons appear before they can process user input. And on our machines, everything loads very quickly. I can click on a button, and even if I'm very fast human, I will never experience the situation where I click before the handler is attached. But slightly slower connection, and you see these transient flaky errors where there is a click and nothing happens. And now real users experience that. Sometimes you enter like your name, you start entering, and then boom, suddenly it disappears. Like the field is cleared because it took a while to load this. Our end-to-end tests can slow down our, for example, JavaScript bundle load and see what does the user see. Can they try entering the name? And what will happen to the input? Will it just disappear, causing frustration? What happens if the user clicks on the button really quickly? Will we actually disable the button initially so the click will not happen until the page is ready? Or maybe we'll buffer the click events and then process them once the JavaScript is ready. So you can do end-to-end testing, right? And see what happens on slower connections. And I think if you really want to create a useful web app, you have to think about this, right? You have to create a good user experience for slower connections.
Got it. So we have more wonderful questions, but we are out of time. So thank you, Gleb, for answering those questions, and thanks to everyone in the audience for sending them in. That brings us the end of the session. Just a quick reminder, this recording will be shared with you over the email, and you can also catch it later on the Airmail or the Lambda Test YouTube channel. So once again, a huge thank you to the Gleb Bahmutov for joining us today, and thank you all for all being in such an engaged audience. So enjoy TestMu 2025, and we'll see you in the next session. Thank you, Gleb. Have a great day.
Take care. Thank you.